Right. So today we are going to start with the next topic in TDMA. Okay. So in the last class we have discussed about the TDMA frame format, how it is present. So today we'll discuss about the TDMA types. Okay, that we have types of TDMA in satellites. Okay. First one is satellite switched TDMA. It is known as SS TDMA. Second one is onboard processing. Okay. So these are the two that we have, right? So these are the two that we have. We'll go with the first one. Okay, to discuss. Satellite switch TDMA. So when you go for this satellite switch TDMA, we can represent in terms of figure that we have. Right. So this is the satellite switched TDMA. Right. I'll make it some more large. Okay. So this is your satellite switched TDMA to have. So you can see here clearly we are having the satellite which is being shown here. Okay, this is the satellite which is being shown. You have earth stations here which have been represented. Okay, these are the earth stations that we have. So this is your transmitting earth stations which have been present. These are your receiving earth stations that are being shown, right? So they are being represented in terms of having the time slots with frames. These are the time slots and frames that are represented here, right? So this is the thing what is shown in this one. So when you go for this satellite switch TDMA, we write in terms of points what makes it to understand. Okay, so it is an efficient TDMA system. Okay, it is an efficient TDMA system. Okay, with multiple slots, with multiple time slots for the operation of uplink and downlink transmission, right? So it is an efficient TDMA system where you are being seen in the figure itself. It is clearly shown that you are having multiple time slots that are allocated for the uplink and the downlink transmission. The interconnection between the uplink and the downlink beams is performed Okay. Is performed by a high speed switch matrix. By a high speed switch matrix. Okay. You can do that in terms of here. So as a satellite switch TDMA is an efficient TDMA system for the multiple slot operations that have been represented here. Right. So that makes you to understand that it is an uplink and downlink transmission, and the interconnection between the uplink and the downlink beams is performed by a high-speed transmission. Okay, so it provides a full interconnection of TDMA signals for the various coverage of the regions. The most important thing is that SS TDMA. SS TDMA is nothing but I have shown on the above now. Provides a full interconnection. Okay, for various coverage of regions. For the various coverage of the regions, we go for this one, which helps it to cover the entire region that is required. So that is the thing which help us to see about this one. Okay. So this is the thing what shown clearly. So you are having at the center with a satellite switch control station. On the figure only it is being shown. You are having a satellite switch control station. What makes this satellite switch control station of earth station? Okay, satellite switch control station, which is nothing but you have an earth station at the ground. So this earth station will help you to have a switching operation of a satellite with the earth station with whom it has to connect. Okay, the bottom you are having this satellite switch control earth station. So this satellite switch control earth station helps you to make the satellite to switch to one of the station to whom it wants to connect. Okay, to whom it wants to connect, and it will connect to with the particular earth station. It will send the data from the earth station to the satellite. Okay, in terms of frames which are being allocated in the given time slots. In terms of frames for the given time slots, the signals of this one are transmitted from the earth station to the satellite. So that is the thing what happens here in this one. Okay, so that's why we are using this satellite switch control station to make the switching operation to take place between the satellite with the different earth stations that are present here, and makes you to switch to one of the earth station with the satellite and makes you to transmit the data to the satellite. In the same way, it will make the switching operation to connect to the receiver side from the satellite to the earth station and makes the data to transmit from the satellite to the earth station in the receiver side also. So this switching operation control is looking after by one of the station in the ground. Okay, by one of the station in the ground. So this is the thing what happens here. Okay, which we have been discussing now, right? So in this satellite switch at TDMA, we will see that the different traffic patterns are provided with a time slot for the information get allocated with T1, T2 and T3 and so on. So what makes it that we are allocating the particular time periods in terms of having these okay, which are being provided. Okay, so we are providing the time slot for the frame. This is called as traffic patterns. So this time slot makes the information to be allocated in terms of T1, T2, T3. So you can see in the figure itself, it is clearly shown where you are having this positions of T1, T2 and T3, which is being shown clearly here. Okay, that makes you to understand this point, right? So the possibility of this one is that the possibility of this one of this SS TDMA, okay, the possibility of this SS TDMA is nothing but it makes the frequency reuse. Okay, the possibility of SS TDMA is to make frequency reuse for the information to get transferred. Okay, for the information to get transferred and to increase the satellite capacity and to increase the satellite capacity, okay, in terms of data store and transfer. In terms of data store and transfer, okay, so that's why we are going for this SS TDMA. And the antennas that we are using in this one makes help of, okay, antennas used in SS TDMA provides a better coverage of region, okay, provides the better coverage of the region in terms of beam width, provides the better coverage of the region in terms of beam width. So this is the thing what happening in the satellite switcher TDMA. So these are some points. And we will continue is with some more advantages about this SS TDMA, because the main efficiency of this one is providing multiple slots for the operation of uplink and downlink transmission, and there is an interconnection between these uplink and downlink to have a high speed of switch matrix, and also the full interconnection for the coverage region is also possible. The different traffic patterns are being provided with the time slots which are allocated as T1, T2 and T3. The possibility of this SS TDMA is to make use of frequency reuse for the information transfer and increase the satellite capacity in terms of data and the transfer of storage. And also the antennas in the SS TDMA makes a key role to provide better coverage of the region for the better band beam width. Okay, for better beam width. So this is the thing what is happening in SS TDMA. So when you go for this one, the next point in SS TDMA is that the use of narrow beam, okay, narrow beam antenna that provides a high gain of coverage region, a high gain of coverage region for efficient the efficient transfer of information. So we are using narrow beam antennas in array format. Most important, we use of narrow beam antennas in array format that help us to see that the information is been reaching with an efficiency of the transfer. Okay, so that is the thing what is happening in this your SS TDMA. One of the advantages is that the use of single antenna beam with the continuous coverage of the entire zone with a narrow beam, which provides an increase in the EIRP. So I'll write in terms of advantage. The most advantage of this SS TDMA is provide a baseband processing transponder, okay, to maintain continuous communication, the continuous communication of entire coverage region. If for the entire coverage region, we go for this type of antenna with that of SS TDMA. This is the most advantages of SS TDMA to provide the baseband processing transponder to maintain a continuous communication in terms of the coverage region, and also as we use narrow beam antenna, it provides high gain, okay, with increase in EIRP, high gain, increase in EIRP. EIRP is nothing but effective isotropic radiation pattern, and therefore increases the capacity in the downlink. Increases the capacity in the downlink. So the uplink received by the satellite are demodulated to recover the bit streams. So the data received from Earth station to satellite is demodulated, okay, to recover bit stream and retransmit them to the Earth station, okay, and structured in a sequence of packets sent to Earth station. Of, I'll write this one, receiver side. This is most important because even though you can't understand, so the data that is being received is being made to have this. Okay, it helps you to have the data from the earth station to the satellite to be demodulated and recover the bit stream and the structured in a sequence of packets and sent to the earth station of the receiver side. Okay, so these are being sent to the station of the receiver side. So this is the thing what's happening in your SS TDMA. Okay, in the SS TDMA, these are the things what are happening that we have discussed now. So this helps you to understand the coverage region, how it has been made in terms of the satellite switch control station, which is present here near the ground, and it is making you to have a switch operation with the earth station that wants to connect with the satellite, so it will connect with a particular earth station and it will take the frames of the data that are present in the given time slot, and those frames are being taken by the satellite and it covers the entire region of the station, and it will take the information and it will retransmit to the receiver side. So we have a narrow bandwidth, narrow antenna beams that help us to provide high gain of the coverage region, which has the information, and this maintains a continuous communication for the entire coverage. So as we are having a narrow beam antennas, it provides high gain with increase in EIRP, effective isotropic radiation pattern. So that helps you to have this type of data transfer from the earth station to the satellite, and it is demodulated and we are regenerating the bit streams, and they are being made to structure in a sequence of packets, and those are being retransmitted from the satellite to the earth station on the receiver side. This is the thing what happens in your SS TDMA. So this is the thing about SS TDMA. Next we go for the next one, that is onboard processing. So when you go for this onboard processing, multiple access techniques are used in a bent pipe transponder, transponder, okay, which simply amplifies the signal received from earth station and retransmit it back, okay, and retransmit it back to the earth station at different frequency. We'll write like this. Okay, so that is the thing what is happening here, which makes you to understand, right? So as the multiple access techniques that are implemented in our transponders, which are present in the earth station and the satellite, using a bent pipe transponder, they simply amplifies the signal and they will be received from the earth station and they will be retransmitted back to the earth station with different frequencies. So this is the thing what is happening here, and the main advantage of the bent pipe transponder is flexibility of the transponder, the flexibility operation of the transponder. Okay. The bent pipe has had a flexibility of operation by the transponder. Flexibility of operation by the transponder. Okay. So this has been considering this most of the time is been the transponder has a combination of the signals, okay, within its bandwidth only. Okay, the combination of signals are obtained within the bandwidth allocated. Okay, so this is the thing what is happening here, which makes you to understand. So we will look after here the ratio of the carrier to noise ratio. Okay, by considering that the transmitting station has a bent pipe and it is sending the signal to the geostationary orbit, and we see that we are having the information transfer by calculating C by N ratio. Okay, okay, we consider an example in terms of taking signals of transmission from Earth station, okay, to satellite before it calculates its C by N ratio. Calculates the C by N ratio. So the overall C by N ratio is a low value, indicates the variation in terms of climatic conditions, due to which low EIRP is obtained. Okay. So when you go for this one to have the climate calculation, we can see that there is the climatic condition variations that makes you to have in terms of the data transfer, which is providing low value of EIRP, effective isotropic radiation pattern. So this low value of effective isotropic radiation pattern, which makes you to obtain the effect of climatic variations in the atmosphere. So due to this climatic variations in the atmosphere, we are not able to provide this information transfer in a better manner, that is obtained by the calculation of carrier to noise ratio, C by N ratio, which we are having now. So this is the thing about the onboard processing of TDMA, which makes you to use this. Okay, most of the time we try to use in the mobile telephone services. Okay, most of the time we use in mobile telephone services on-board processing and Ka band satellites provided with internet access. Right? So we use this one in most of the applications of mobile telephone services of onboard processing in the satellites and also in the Ka band. Most of the time we use in the Ka band satellite services with the internet access when we are having. So this is the thing what we have about the satellite switcher TDMA and onboard processing that we discuss, right? So other than these two, we have another one, the same name only, no change at all, which is called as SS TDMA with onboard processing. Okay, we have another one that is SS TDMA with onboard processing. So what this makes you to understand? It is the combination of you can the name only says it is a combination of SS TDMA technique, okay, with onboard processing transponder, okay, onboard processing transponder which we have that help us to understand. So the data is transmitted in terms of packets, okay, from the satellite with a address value stored that identifies the Earth station to which to be sent. Okay. So the data packets in terms of the data is transmitted in terms of packets only here. These are being transmitted in terms of packets. So the packets that are being transmitted will have with an address value stored in the packets only that help us to understand to which Earth station we want to send the data. So the data is been consisting of a header bit and the traffic. Okay, the internal bits in the packets are header bit with traffic bits. Header bit with traffic bits that are present, and those are being transmitted to your Earth station. Okay, so this SS TDMA with transponder provides better throughput of the device. better throughput of the device. What is a better throughput is nothing but better efficiency of data bits transfer, which avoids the error in the data bits that you are transmitting. So that is the thing what happens here. Okay, it provides the better data bits transfer is nothing but it is able to provide the data with better throughput, means better efficiency of bits transfer, which is possible here, which makes you to have a better antenna gain and beam width. Okay, provides better antenna gain and beam width of the information. Better antenna gain and beam width of the information. So that is the thing most efficient means which is providing throughput. What is meant by throughput? Better efficiency of bit transfer without error. That makes it to provide throughput as a meaning and provides better antenna gain and the beam width of the information. So this is about the TDMA process that we are having. Okay, just briefly we'll look after and we will go to the next one. So this is the types of TDMA in the satellites. So the satellites with the TDMA. So the figure shows clearly there are multiple earth stations that are been there, and you are having a satellite switch control station at the center, and you are having on the other side another earth stations which are acting as the receivers. So the efficient TDMA system is nothing but we provide multiple time slots where the frames are being generated and those are being allocated in the given time slots for the uplink of data transfer. So this will have full interconnection of entire coverage of the region that is required. So this satellite switch control station which is present will make you to switch the satellite to operate that wants to connect to a particular earth station. So the switching operation will be controlled from the ground station with the help of earth station only, which is called a satellite switch control station. Okay, so that helps you to understand that we are switching the satellite to connect with a particular earth station and take the data in terms of frames. And also, if you want, it will connect to the another earth station on the receiver by switching operation, and it will give the data or receive it to the other side of the earth station. So it is providing an increase in the capacity of data storage, and also it will have a narrow antenna beam. Okay, narrow beam antennas in array format that provides the high gain of coverage region. So this provides good coverage region where it provides an increase in the EIRP, effective isotropic radiation pattern. And therefore, it increases the capacity of the downlink. And also, it will be received, the data is received from the satellite to the earth station, is demodulated, and those are being framed in terms of bits, and those are being converted in terms of packets and retransmitted to the earth station on the receiver side. So this is about SS TDMA. If you go for onboard processing transponder, this is a multiple axis technique that uses a bent pipe transponder which provides a amplification of the signal, and it is transmitted to the satellite, and also it is given to the earth station at different frequencies. So why we are using bent pipe transponder is it is more flexible to operate for the combination of the signals that are combined with the bandwidth allocated. And if we consider an example, by taking the signals to transmit from an earth station, we will calculate the C by N ratio first. The overall C by N ratio is very low value. It indicates that there is a variation in the climatic conditions. So what are the climatic conditions? Which are nothing but you may have the rainfall or you may have some other atmospheric changes that makes you to have the interruption in the signal, and you will have low EIRP. So most of the time these are being used in the mobile telephone services and also in Ka-band satellite services. If you go for the another one, which is nothing but combination of SS TDMA with onboard processing transponder, the data is transmitted in terms of packets, from the satellite to the earth station. In that packets will have an address value that specifies to which earth station it has to send the data. So internally we are having the header bit with the traffic bits. What are traffic bits are nothing but original information. These bits are being provided by the transponder to transmit with a better throughput. What is meant by throughput? Which is having a better efficiency of bit transmission to the receiver side of our station without error. Without error, if you're transmitting, that we call it as better throughput, where you're having better throughput of bits that are being received to the other side. And also provide the better antenna gain and the beam width of the information that is provided. So this is about SS TDMA with onboard processing. Okay. So this makes you to understand the data, right?